So the next one, these are two papers. Um, Willie, you,
Yeah,
I,
this group I'm familiar with. They are from the University of Science and Technology in Hefei, China. And this
yeah,
group are very powerful. They've been studying actually using biological kind of proxy, what we call proxy, to study climate change here to study sea ice condition. So they study this, what you call Adelie penguins in the
yeah,
Ross Sea region of Antarctica, and
yeah.
kind of clever study actually. And
Y-
Ronan, maybe explain what the study
Well,
tries to
yes. So Willie has decided for the last two, for these two next papers, to talk about seabird poop. And I don't know. That
and
seems to be
penguin poop, the guano or
yes.
something. Yeah,
Yeah. So we have penguin poop, and then we'll have the petrel stomach oils. So this one we're looking at penguin poop, and what we're doing here, this what these guys realized is they were able to get a record of
yeah.
the sediments off this island, Inexpressible Island is the name. That's the name of it, and they're occupied by these penguins. You can see it's one of the regions where just this one up here, and there's other regions where they haven't. But they focused on this. They got a sediment core, and so they were able to see how much penguin poop there was at the different layers in the things. And just to show the penguin, this is a nice photo I found by Robert Scott that he took it. Scott um, was one of the first groups, along with there was a rivalry between Raoul Amundsen was leading the Norwegian group, and Scott was leading the British group, and so they both got to the South Pole. Unfortunately, Scott's team didn't make it back. But before they headed out to the South Pole, they took photos of these nice penguins. So, really, did you want to?
Yeah, I just want to say this is so-called geochemical analysis, right? They just basically, analyze all the different chemicals in it, calcium, magnesium, all what have you, all of it to try to study, right? And then of course the abundance of it. The main feature is that there is a medieval warm period in basically Antarctica, because you may have heard from Michael Mann, the great Professor Michael Mann, that middle warm period only exists in a very tiny region in Greenland and in Europe. That's about it, right? Not elsewhere, because they have proven through his hockey stick misrepresentation, saying that it couldn't happen in. Here's a direct proof: it happens in Antarctica. I often like biological indicator for a very simple reason, because this is the most complex. If the climate were to be not truly warm, or what you call with abundance of food and krill and all this other stuff for the penguin to consume, or that require less CI obviously, then nothing like that could happen actually. Even warm itself doesn't explain it, but to enrich the whole biological kingdom from the ocean plankton, phytoplankton, all this other stuff, and to the point where you can produce krill and small tiny fish for the penguin to eat, you really have to have very sustained warmth. I'm just saying that this kind of study is quite comforting in the sense that it's quite definitive. I would say, yeah, if you want to challenge that middle warm period doesn't exist in Antarctica, you really have to explain this study. Why?
I will put in the clarification because this is a proxy, and so just to explain what they're doing is they're saying that when there's less sea ice off Antarctica, that the population is thriving, and so what they can say is looking at the incidents of penguin poop again to use the technical, that's
Right.
not the technical term, but you can read the paper for the technical things, basically penguin poop, that there was a huge peak in around like 750 to 1250 now, and then they go up to now. There seems to this seems to have been, oh, we've lost hang on, let's put you back in there. We There seems to have been colony was doing much better in that era. That doesn't necessarily mean that it was hotter, but it says it was possibly warmer, but it was at least as warm back then as it is now. The colony was doing well. Michael, did you want to add something there?
Yeah, well, the thing is, we do a lot of experiments with things like krill and various copepods and that sort of thing. And what we find is that if you raise the temperature by 7 degrees, you double their metabolic rate and their reproduction rate and everything else like that. There
Yeah.
is an old rule for which Arrhenius got the Nobel Prize for, which for chemical reactions, if you raise the temperature by 10 degrees, you actually double the rate of the reaction. But biologically, because of the effect of enzymes and various things like that, it seems to be about a 7 degree rise in temperature will double the metabolic rate. So that means that if the temperature back then rose by 1 degree, you'd have a 14% increase in the rate of reproduction and metabolism of the cold-blooded organisms.
Yeah, yeah. I wanted to add in that clarification that rule only applies to cold-blooded
Okay.
organisms, but it can indirectly affect warm-blooded organisms, which includes birds, because it increases the amount of food.
Yeah.
So that. So even though the warm-blooded creatures can self-regulate, it can increase the biomass. Yeah. So Willie, what to add
I
something
just
else?
want to summarize this so we can move on to the next paper for
Yeah,
the other side of Antarctica, where
yeah,
this study essentially compiled this geochemical analysis and then find that during this medieval one period, they say it's about 800 AD to about 1400 AD, right? Roughly that region, where they actually combined with some proxy from, including talk about how the sea ice, the polynyas, and then they also have the southern annular mode, SAM, and then ENSO, which is very strong to, affect the coastal region of Antarctica. They basically synthesize the whole studies and kind of shows how this thing, it could be a very serious reality and one we should just study more, because nature by itself without any carbon dioxide would actually varies quite a lot. And here's one of the very prime example. And then of course the study just appeared a month ago, basically I forget what year, but maybe quite
yeah.
recently.
Well,
And
now let's if we go on to there's a
next paper.
okay. If you put that on mute, Michael.
Yeah.
Yeah. So this is a preprint.
Yes.
So this has just been submitted here. Is again we're looking at birds. In this case, we're looking at the snow petrel, and we're looking at the stomach oil deposits. And so this is taken from this particular region. I don't know if you can see if you're looking on the screen. There is I'm pointing at the map of Antarctica to show the site. And if you look at the screen, this region in purple is the average sea ice extent in the winter, and the region in the red is the average sea ice extent in the summer in Antarctica. And so you can see this is a region where currently the sea ice is free in the summer, but not in the winter. And so if we can move on to explain, this is literally this is what they're looking at. This is the sediment. How
That's the
how big
data.
is it, Willie? It's quite small.
Yeah, it's 18 19 centimeters. I mean, well, let me get my ruler. It's somewhere
Yeah,
like this. Yeah,
yeah,
but
yeah,
one interesting thing is, of course, this snow petrel is actually only one of the three species that's been found flew in to South Pole region. And I think this is another very smart study. You see a lot of this study I tied to individuals that I studied them before. It's headed essentially by a guy named Dominic Hodgson from British Antarctic Survey that I really follow his study. He's very actually a good quality scientist who study a lot of this sort of thing, and I find another very interesting kind of work, because basically again geochemical analysis here, of course, studying the stomach oil, so they'll be doing lipid study, different kind of lipids compound with different alkenes and all that stuff. So it's a very interesting innovative study to try to see about the sea ice condition, because the amount of the thing they eat, the geochemical analysis can tell you the stomach oil, right, can tell you the sea ice, whether they are foraging near the coast or further away, pelagic, that kind of stuff. So
yeah,
read all you want about it in this paper, but we just want to summarize for you that this paper can tell you the condition of sea ice around Weddell Sea, of course, in slightly
yeah.
northeast of
I
Antarctica.
Yeah, and what we can say is that so their sediment could go back to roughly about 500 AD, like, or maybe around 100 AD. But it that's when it's that the earliest, the most recent point. But it goes all the way back to about 6,500 BP. So BP is years before present, where present is defined as 1950. Could get into that. Let's stick to BC. People are more familiar. So to get to BC, it's like 2,000 years, 1,950 less. So
Right.
than that. Okay, and so what they found is looking at the from the stomach contents that
The
they're
oil.
finding in the deposits, they're able to infer how much krill and how much fish they were eating at the time. And from that they were able to realize that actually around 4500 BC, they were having similar uh, food sources to similar amounts of krill and fish than they are today. So that means that the ice coverage conditions were similar in 4500 BC as today. But then it got worse and worse. So at the end of the ice core, a lot more ice cover. Michael, did you want to add something?
Yeah, similar sorts of studies were done in the Arctic sea ice extent. There was an algae that lives in the sea ice or in the ice. It's an ice algae, and when the ice melts, the algae is eaten by um, small shrimps, and again that produces a certain fatty acid profile. And again, by looking at the sediments, we find that there are similar melting of sea ice extents in the Arctic.
Arctic. Yeah, yeah, that is during the Holocene period, like Bronze Age and even earlier. You're referring to the PIP 25 proxies. Maybe we could do another talk on that on another episode.
Right, right, right.
Did you want to wrap it up then?
Yeah, I kind of want to wrap up because the word polynyas happen all the time on this graph and pictures. People, maybe you need to look up, of course, what is the polynyas, right? It's basically a warm region that's surrounded by ice. So warm time, you actually would have a lot of polynyas, or in
Yeah,
fact, no. And then when there's no polynya, that means the whole thing is covered by ice. So that's cold time. So that's the one that 2,600 and B to 50 BC that mark over there. So there are three episodes in this particular study, obviously, that they found.
yeah,
Right, the warm, cold, warm, that kind of thing,
yeah.
intermediate. Yeah.